In this example, I've designed a horizontal and vertical alignment that I want to use as the center line for a new overlay design. The Overlay Design Template method menu is available if you have a MXRENEW or a MX Road Suite license. You can use this option to design an overlay scheme using a series of templates which honour the design speed along the alignment. So we'll type a new scheme name, click Next, Function Control Panel appears. So we need to use the Define Surfaces wizard to specify the road centre line, the ground model and the road edge strings. Now note that these road edge strings are optional. You can have gaps in them, so they could exist at the start and the end of the scheme but not in the middle, or you don't need to specify them at all if you don't want to. So you can use this functionality in a greenfield site. So we'll just process through and we get the cross-section graphic showing our existing pavement in white and our existing ground outside of that in the dashed green line, so we can just step along the chainages, making sure there are no anomalies in our survey. Once we're happy, we can click Finish to return to the function control panel. The overlay depths and crossfall tolerances options could be used next, but they are available inside corridor design, so we'll go straight there. The corridor design panel has a menu bar and a range of views which you can select from the pull downs. Here we've got the cross section view and the editor shown. The first thing I need to do is set my design speeds. I'm just going to highlight all the rows and set a design speed of 70 kilometers per hour. The process now involves working through these icons across the bottom of the screen, setting up the options that I want. Now I'm going to start by saying that I want to match the existing road edges, and I'm going to specify a nominal crossfall to start with, 2.5%, and I'm going to right click, add a row, and then say at changes 20 I want to start joining to a template starting at chainage 40, and that template in this particular case is just going to be a single two-lane template. Now note that these templates do not have to follow the MX Road string naming convention if you don't want them to. You can set it up so you've got CL for the left edge, CR for the right edge, for example, if you want to. In this case we're just going to use the MX Road string naming convention. So we're matching over the first 20 meters, then going to a join before we get to the template at chainage 40. So next icon along, superelevation rules. I'm going to use a single carriageway superelevation rules file. I've then got a curve widening option which will automatically widen the road width around the curve if I need to. The curve in this case is not particularly small, so I don't need to use it. I've then got an option to design shoulders. I've then got a crossfall tolerances option. Now I want to tie my design crossfalls into the existing crossfalls just at the start of the road, so I'm going to give it a 2% tolerance and then say I'm going to add a row, and at chainage 30 where I start the join to my template, I'm going to say I actually want to use the design crossfalls, so I'm setting the tolerance back to 0. Working on through the options, I'm not going to specify overlay depths in this case because I've already got a vertical design from my alignment. I am going to specify curbs, verges and footways, so I'm going to select a template for that and then right click, add a row. The software is assuming that I'm going to specify the next section on the left hand side. In this particular case I want to specify a template to use on the right hand side. I'm going to use the same template again, but do bear in mind you can swap between templates on each side so that you can vary verge widths or earthworks or whatever you might need to. So the final tab is for Earthworks. So we'll go and specify, we'll just start by using a simple slope in the 4 quadrants here, so left and right, and then add a row again. And again, I want to go on the right hand side, so just specify that same simple slope for the other 2 quadrants. So that's all the information set up. We click the refit button. We now process all of that information. We apply the design speeds, the road template, the super elevation, the crosswall tolerances, the side slopes, and the curved verge and footway templates to build up the complete road cross section. We can see that we've got some annotation in the plan view. Crossfalls and contours are being shown in this particular case. Just increase the size of that text a second. Okay, so we can see that the design speed of 70 kph on this radius means that we need a 2.5% super elevation. Just turn on the tracking option, move up to there, right mouse click to turn tracking off, and we can see the super elevation in the cross section view here. Just going to zoom out slightly because I think further down the scheme, yes, we're into some cut here, into sidelong ground. We've got some cut on the right hand side. So what I might want to do is specify that in that case I want a ditch. So I'm going to select my cut with ditch template here, click OK. I just need to set the Earthworks strategy to analyse the fill before the cut, then click the refit button to reprocess the design. And there we can see how the ditch has been generated in cut on the right hand side. Again, the plan graphics have been updated to show that change in the design. And we've got full undo and redo here, which we can use at any point if we want to step backwards and forwards through our design steps. But I'm going to make a change now to the design speed. In this example, I'm going to change the design speed over the whole length of the alignment, but I could do it over particular tangent point ranges if I wanted to. So let's just increase the design speed to 85 kilometers per hour. Click the refit button again, which reprocesses the whole design. And as you'll see in just a moment there, the plan graphics have updated. We can see the crossfalls have changed to 3.55%, so more super elevation on the higher speed. We can have a look at the super elevation diagram if we want to, just to see what's going on there. So we can continue using these options now, changing parts of the design as we see fit until we've got a suitable solution. At this point I'm going to click Finish, which will reprocess the design again in case I've made any changes to any of the tables without clicking the refit button. So it's going to reprocess the design and return me back to the function control panel. At this point I could analyse the through visibility, checking for possible problems there. If I find any problems, I could go back into corridor design, perhaps widen the verge template if I've got cut which is blocking the visibility. I could also, if I wanted to, use the cross-sectional editor to widen out the verge in that situation. Then I can continue on through the process further down the function control panel. But these options further down are common to all of the methods we're looking at today, so I'm going to cover them later.